Good morning, everybody. My name is Roger West from Trinity College Dublin, and I am to be your chair at this, the second session of the BIM Gathering 2021. And you're almost welcome to this session. We've just experienced a number of really very good keynote talks, which have set things up very nicely for the 3 days. This is the session in Stream 2, which is on BIM standards and Open BIM, and we have 3 papers to present. And as is the case throughout the 3 days, can I encourage you, please, to use the Q&A on the right-hand side of your screen, and we'll allow the speakers to make the presentations first, and then I will orchestrate the questions with the speakers. The first of our speakers is Brendan Joziasse, and he's a senior architectural technologist working with Henry J. Lyons Architects. He has experience ranging from high-profile commercial projects to mixed use and large-scale residential schemes. He is a key member of the HJL BIM leadership team and initiated the HJL Dynamo user group in order to establish and develop Dynamo workflows to increase productivity and efficiency by automating daily tasks. And his talk to us this morning is entitled, "Can current BIM standards and technologies be applied to and adopted by facade consultants and contractors to meet their needs and the requirements to be BIM Stage 2 compliant?" Brendan, you're most welcome, and I invite you to deliver your talk, please.
Thank you, Roger. Good morning, everyone. Thank you for joining my presentation on the application of BIM process and standards in the context of the facade manufacturing industry. My name is Brendan Joziasse. I'm an architecture technologist and BIM coordinator at Henry J. Lyons. I graduated from the architecture technology program in 2010 from DIT, or TU Dublin as it's now known. And more recently, I've completed a master's in applied building information modeling at TU Dublin, and the research of which I'm presenting here today, which formed part of my dissertation. The co-author of my paper and supervising during my dissertation was Emma Hayes, who's a managing director of Digital Build Consultants Limited. Emma has an MSc in BIM management and is a chartered architectural technologist with over 20 years experience in the AEC industry. So most will already know the AEC industry has seen a steady increase in the implementation and use of building information modeling. The NBS National BIM report published in 2020 indicated that 73% of those surveyed are aware of and currently using BIM, compared to only 13% in 2011, so a steady increase. The same thing is largely reflected in my own experience over the past 7 or 8 years. However, one thing I've noticed is a large aspect of each project, the facade, almost never became part of the BIM process. By that I mean facade information was typically produced using AutoCAD, which meant coordination became more problematic than with a BIM model. That's not to say BIM models are not produced for facades. Typically when they're produced post-project completion, or models are completed in part with AutoCAD-based drawings. This led me to my research question, which was to investigate if current BIM standards and technologies can be applied to and adopted by the facade industry to meet their needs and requirements while also being BIM Stage 2 or Level 2 compliant. This research primarily focused on the early stages of the facade production, from tender through to the generation of shop drawings for approval. The focus for the literature review was in 2 areas: the typical construction process and barriers to BIM adoption. As there was limited research available to the facade industry, the research was focused on identifying and understanding the common barriers to BIM adoption in the AEC industry, of which there are many, and to determine how these may apply to the facade industry. Studies show the process involved in realizing a construction project from initial concept design to construction has remained largely unchanged over the last 5 decades, stagnating behind agriculture, forestry, fishing, and the manufacturing industry, where productivity has more than doubled over the same period. As there are many barriers to BIM adoption, 5 main areas were focused on to gain a better understanding of what the AEC industry has experienced and how this may apply to the facade industry. Unfortunately, I won't have enough time to go into great detail here. However, the research paper is included in the conference proceedings. So there were 5 areas which were as follows: barriers associated with BIM, technology barriers, and people and human factors, business associated factors, and external barriers. The overall aim of the research was to investigate the current state of BIM adoption in the facade industry and to evaluate a possible workflow to satisfy all stakeholders of a construction project by fulfilling the contract BIM requirements. To gain a better understanding of this, semi-structured interviews were undertaken with industry stakeholders, encompassing 6 facade subcontractors, one of which had already begun a transition using BIM workflows, 2 facade specialists, and 2 main contractors. The later 2 groups have all implemented BIM processes in their day-to-day operations. Interviews were based on the literature review findings and broadly comprised the 5 following areas for discussion: process and common practice, which is to identify the typical process undertaken by all participants. And barriers associated to BIM include knowledge and understanding to establish how familiar each interviewee is with BIM, business and external barriers to establish if a lack of BIM awareness and strategy has hindered BIM adoption, and technology barriers to determine which software and technologies are used, including BIM software, and interoperability issues experienced. Typically, all interviewees were involved in post-main contract award and the subcontractor appointment stage and remain involved throughout the construction process, including handover. The typical process comprised 3 main stages, from tender to site assembly, a tender preparation and proposal stage, a 2D detailed design stage, and subsequent production and manufacturing stage. For 5 out of 6 facade subcontractors, this process was largely dependent on traditional methods for production of information using AutoCAD and Excel. The subcontractor I mentioned in the previous slide had just begun to incorporate SolidWorks into their process for implementation of a BIM-capable workflow. And early indications suggest that there was some day-to-day disruption to their process and some slowdown. However, they were confident that BIM software would enable them to be more efficient on sprint projects compared to 2D CAD workflow, and they intend to use the model through all stages from the beginning through to fabrication. When asked about individual resistance towards BIM adoption within their company, the consensus from the facade subcontractors was one where no resistance was perceived. However, both the main contractor and facade specialist have experienced a reluctance to change within their organization and from other subcontractors within the facade industry. This was predominantly attributed to a lack of knowledge and understanding of what is required when engaged in a BIM process. The day-to-day disruption experienced by individuals can lead to discomfort and resistance to adopting BIM processes. Therefore, it's important to illustrate day-to-day benefits a BIM process can provide to all those involved in construction. Both main contractor and facade specialists have already adopted BIM processes and workflows throughout their practice. While the consensus among the facade subcontractors is one where BIM provides no added value to their current processes or influence on business decisions, which may also stem from a lack of knowledge, understanding of BIM processes and technologies. So BIM is viewed as an asset towards the end of a project. So that's to say, a BIM model is produced as a bolt-on or additional service only when required, and not part of their design process. Where pressure was experienced by subcontractors, this originated largely from the main contractor, who in turn have experienced increased pressure from clients. Typically, when pressurized to deliver a facade BIM model, interviewees found that the BIM requirements were often dropped in favor of cost saving, provided all documents shared on the common data environment followed the BIM naming protocols. Interviewees had mixed feelings when asked if government should be the driving force mandating BIM on construction projects. With no requirement mandated for BIM deliverables, facade subcontractors remain hesitant to adopt BIM practice unless pressured to do so by contractors as part of their BIM process. One of the interviewers expressed that it would be good to see government-backed BIM mandate for all large contracts. However, their concern was that the government did not have the experience to be able to deliver a BIM mandate, and a lot of the responsibility falls on the main contractors. Interview data indicates AutoCAD as the most prevalent software used by interviewees, followed by Revit. There was a clear divide between the facade subcontractors and the other interviewees who typically used Revit and AutoCAD in their day-to-day operations, while the facade subcontractors were found to predominantly utilize AutoCAD and bespoke manufacturer software throughout the process, such as Wicktop, Rainer Pro, and Logical, some of which don't actually provide BIM workflows or have difficulties with interoperability with other software. Both the facade specialists and main contractors were found to use Revit as their authoring tool for day-to-day workflows, while the consensus among the facade subcontractors was one which doubted the capabilities of Revit as an authoring tool for the production of drawings and information, despite often delivering Revit models based on the 2D CAD drawings. So these models were typically outsourced to third parties and created on signed off or approved 2D information produced in the earlier stages of a project. This practice of creating facade models based on 2D CAD information caused some concern with the facade subcontractors, who questioned if their drawings are correctly interpreted when creating BIM models. So it does acknowledge that my study was only of a small sample of 10 interviewees, and 6 of which were facade subcontractors or manufacturers. As such, interview findings suggest barriers around BIM adoption in the construction industry remain prevalent with respect to participants active in the facade subcontractors in the study. As BIM increasingly becomes more prevalent in the construction industry, it is vital for facade subcontractors to be able to respond to and meet their contractual obligations where BIM Stage 2 or Level 2 processes are mandated by the client. To enable a change of practice in the facade industry, it's vital to promote training on BIM processes and technologies to encourage new ways of thinking and enable business owners and employees alike to make informed decisions around BIM adoption. Within Ireland, there are a multitude of avenues for further education on many topics surrounding BIM, ranging from seminars, conferences, and CPD events to structured training at third level through private companies or online. For the current process to undergo change and integrate with BIM technologies and software, facade subcontractors will be required to reevaluate current practice and identify how BIM technologies can be integrated in a new process to meet their day-to-day needs at each stage of the construction process. Where presently BIM models are created after the fact, integrating BIM processes would enable increased coordination between facade subcontractors, the main contractor, and the design team. The process workflow seen here proposes to include a BIM model at each stage, whereby the model is continuously updated from one stage to the next. And all drawings and documentation are derived from the model, which is federated into the asset information model at the end of construction. So using Autodesk Revit, software that's widely adopted in the industry, my research explored the feasibility of creating a BIM model capable of producing a documentation set typically generated by facade subcontractors. The sample drawing shown here is of a project that I'm familiar with. The slide shows a typical general arrangement drawing consisting of a plan, elevation section, and a 3D isometric view, as well as takeoff schedule for curtain wall panel sizes and quantities, mullion transom, and cap profile lengths. And this can then be further developed into detailed drawings as the project progresses. Further process improvements are available through utilizing sample models which contain pre-configured curtain wall systems which can easily be copied into new projects, inclusive of model data used for scheduling and annotating. Furthermore, software plugins such as Dynamo BIM, a visual programming environment which gives users the ability to visually script behavior, define custom pieces of logic, can be leveraged to gain efficiencies by automating repetitive mundane tasks. So these could be tasks such as placing structural supports or populating parameters in the facade, or even tagging, as well as aiding QA and QC are further areas where process efficiencies can be achieved through using tools such as Dynamo BIM. Within the construction industry, there are many outlets for discussion of construction and BIM-related topics such as the monthly CETA Technology Trend series, or indeed the actual the annual BIM gathering, which provide an open platform or an open forum to all their members. Throughout the data collection process, several interviewees expressed a lack of such an open forum aimed specifically at the facade industry, stating they all exist in their own little pockets with very little interaction between competitors. An open discussion forum may provide a means to close a disconnect between the facade manufacturing side and the design side of the industry, and provide an opportunity for all disciplines to converge, openly discuss the expectations of one another, and identify potential problems and solutions based on industry stakeholder experience. And that's it for me. Thank you.
Brendan, thank you very much for a very interesting introduction to the use of BIM in the facade industry, and I'm sure there'll be some interesting questions and answers on that. If I could just remind all the listeners that please do use the Q&A facility on the right-hand side of your screen, and we'll take all the questions at the end. We're now going to break the rules effectively and have the chair actually present. And I'm very happy to do that because I wanted to talk to you about some research I've been doing with Alan Hoare and Barry Macaulay in relation to digital construction and BIM research in Ireland over the last 5 years. And many of you will be familiar with these 3 documents, which were produced a number of years ago, whereby a global BIM study was undertaken by CETA. And at the same time, we looked at the state of the industry and indeed education in Ireland, followed by a duplicate study in 2019, which updated us on what the progress was. Subsequent to that, of course, oops, beg your pardon. Got it. Yeah. Subsequent to that, and indeed previously, this is the 5th of the CETA BIM gathering. And these are the proceedings from the first 4, and there'll be proceedings, of course, from the current one. And this has really been a very rich source of information for both industry and academia. And indeed, as academics have as part of their responsibility to publish in conferences and journals, it has been a very rich avenue for us to share our research nationally. A couple of years ago, I, together with Alan and Barry, conducted some research on the publication of BIM conference and journal papers on the island of Ireland. And we published that actually last year in the Civil Engineering Research in Ireland conference. And we got a very good feedback. And the purpose of it was to effectively develop a repository of knowledge, so that one of the fair criticisms of academia is that we work within our own areas and we work internationally, but we don't always know what's happening in other academic institutions in Ireland. And the likes of the BIM gathering is a very good way for us to network and to find out what other people are doing. But there is no coordinated database of all the information. So the intention of this was to see exactly who's doing what in BIM research. And this was published, as I say, last year. And when we did the work on this, we found that there was a lot of other papers which have been developed in digital technology, which in construction, which in fact we missed in the paper. So the purpose of the current paper is to broaden out the remit of the group of 3 of us to include all Irish academics to consider what papers they had published in the last 5 years in digital construction, basically who's doing what in the industry. And as I say, it was inclusive to all academic institutions on the island of Ireland. And the objective was very similar to the previous paper, except for digital construction, to identify all the papers that have been published in both conferences and journals internationally by Irish academics. And this would be a reference source for students who are starting off in their projects, for academics to try and develop further collaborations, and equally importantly for industry. So if they wanted to know who were the people who were working in this area and they wanted them to work with them, is they would know very quickly who these people are. So it was basically just essentially to develop a list of expert academics working in digital construction, which would include, of course, BIM. And when we analysed the information, it was interesting to see where the potential areas for future research might be. So that was also one of our objectives. The methodology we used was the tried and trusted method that we used before, and that is we contacted 16 out of the 22 academic institutions on the island, those who were known to be working either as teaching or research in digital construction, and to identify a contact point in those institutions and ask them to locally investigate what the extent of their publications of themselves and their colleagues would have been over the last 5 years. Now, we had originally hoped to include all MScs and PhDs and technical reports, because these are also a very rich source of information. And certainly while we store these documents in our libraries, we don't often go to each other's libraries to find out what's there. So it's really only if papers are produced from these very extensive reports and as a consequence of very extensive research, do we actually get to find out what other people have been doing. So that wasn't possible due to COVID, because people couldn't get access to their own libraries and indeed their own shelves. Anything that they didn't have digitally was going to be hard to find. So we had to abandon that, unfortunately, but we still have hope to do that in the future. Furthermore, we had a very heavy reliance on the academics because we relied on them to actually tell us what their peers were doing and to find out from their peers what they were doing. So I'd like to particularly acknowledge with thanks the work of all of the people who are listed here from the various institutions, as you can see on the screen, who acted as our mentors and our contact points so that we could liaise with them to get the information back. So thanks to them indeed. Just to let you know, in total, there were more than 250 papers. And when we looked at those, a number of them weren't applicable because they fell outside the 5-year time span, or indeed they weren't in the area of digital construction. So we had what we deemed to be 167 valid conference and journal papers over the last 5 years. And very early on, it became clear that the biggest cohort within digital construction was BIM. It's been very well established over more than the last decade. And the other areas of digital construction have been developing significantly and very quickly. So you can see the breakdown on the left-hand side there, that around about half the papers that we were told about that existed were in BIM as a subset of digital construction, and about half in the other areas. And I think it was also very encouraging and pleasing to see on the right-hand side, this is not a bad statistic actually, that around about a third of the papers were published in international journals, and the other 60% were published in conferences, both national and international conferences. So normally journals are a slightly smaller percentage, but it was very good to see that the academics have been publishing extensively in journals over the last 5 years in digital construction. Now, again, you might expect me to use electronics and digital tools in order to sort the 167 publications out. Actually, sometimes just because the technology is there doesn't necessarily mean you have to use it. I found it actually much more useful to set them out on a table, as you can see from this photograph. There's 167 papers here, and I was able to categorize them and move them around and find them very, very easily, and break them down into cohorts as to which people were working in which sub-teams within each one of them. And then once I'd done that, then I could go back to the digital process. So I thought it was quite interesting that when talking about digital construction, I didn't use normal computer facilities to establish what the groups were. I just found it much easier to work for a couple of hours on a kitchen table to do that, which was interesting in itself. Having said that, let's look at the results. I broke them down into categories as I saw them, and you can see here what that breakdown is. So you can see where the key areas have been: the digital age, remote sensing, building energy and education, with a number of other ad hoc papers. So there's really only one or two major themes there, as you can see, probably remote sensing and digital age as the main themes. And I have a discussion on those in the paper if you want to read more about what was involved in those. That's on the non-BIM side. On the BIM side, there was a lot more subcategories, again, very well established. In a way, not surprisingly, education was the highest or the largest cohort of these. So a lot of people have been introducing BIM modules and courses and whole degrees within their own institutions. And this has been widely reported in the publications. And indeed, if you go back to the BIM survey, global BIM survey, a number of years ago, we certainly found that Ireland was performing very well in the educational sector in terms of introducing BIM into our curricula and into our research. So it's not surprising that was a big cohort. The other areas, just to note them there: knowledge management, thermal performance and digital twins, and two subsectors of BIM. There's a discussion on each one of these in the paper. I don't intend in discussing them here. And in particular, there's a number of use cases which are very interesting to see how the industry has learned in its BIM journey as to how to adopt BIM. Now, one of the things I could do electronically is for every single co-author and author in the list of references, I was able to identify who had been publishing what. And this is the top 50 publishers of the authors and co-authors of the various papers. And I'd just like to draw your attention to just three distinct cohorts: Comiskey and McCain, and not necessarily publishing together, but they have worked in technology, data sharing, and education. You can see they've a significant number of publications. Secondly, in the by Motto and O'Donnell, in the area of big data and building performance, highlighted here in blue in the table on the right. You can see the significant number of publications, and of course the numbers that are there in this list refer to the number in the list of references, which you can find at the end of the paper. And then finally, some work that Alan and Barry and myself have been working on over the last 10 years in both BIM and education. And again, you can see that highlighted in green. So from this, we were able to identify a number of growth areas, and I won't dwell on these. There's comments on these in the papers themselves, in the paper itself, if you want to care to read it. But certainly remote sensing has been growing, the whole area of dynamic digital twins and how that ties in with BIM, and in particular how it ties in with building performance and assessing the sustainability of the construction and post-occupancy assessments, and how you feed that back into a digital twin. As PJ Rudden mentioned this morning, the whole lean construction, sustainable construction life cycle analysis is going to become increasingly important. And again, there are very significant avenues there for using digital tools in construction to perform all of these, very absolutely essential in climate change agenda. And some of the observations so far relatively modest, I might say, in comparison to other areas like transport, environment, and concrete. We still have a relatively modest number of publications. That's 30 per annum on average in total for the entire island. So in concrete technology, which is another area I work in, for example, is typically 60 to 70 papers per year. So this is a growing cohort of people who are working in this area, and I think it's going to just explode over the next 5 years for sure. And what has become apparent, though, is the importance of the BIM gathering in allowing industry and academia to network and to find out what each group is doing. And there's been an awful lot of collaborations are taking place, not least in what Brendan said earlier, that type of a collaboration with industry. Now, just to note that I would say that the list that I have produced is not exhaustive. I did rely on the people within the various institutions, 16 of them. So there may be some other papers that we haven't been able to find because we didn't get the feedback. And I'd be very interested to hear about those. And I would also be very interested in expanding it out to produce a database of MSCs and PhDs, which are a rich starting point for any new researchers. So in my closing remarks, we have what I hope will be a useful list of papers in the different areas. So I've certainly got a lot of good feedback from both industry and academia and from students saying, you know, if I'm starting out a project or I'm working in a particular area, it's very good to know who else is working in that area. I think it's very positive that we have so many journal papers, and I'd like to see that continuing. And as PJ Rudden referred to earlier, it's absolutely essential that we find that the funding is in place, either through government or through industry or through international collaborations through the usual channels for funding research, that we manage to not only attract but keep the really young talent that we have. And I've seen this in other areas where, you know, things tend to drift and the funding isn't there because there's no impetus to do that. And the young people inevitably are hungry to do research and they drift off into other areas. And we'd like to encourage the young researchers to not only be trained and to be educated to use it in practice, but also to continue on the research that's so essential. There's an enormous amount of research that needs to be undertaken. And I was mindful of the roadmap with regard to digital transition and to suggest that what's going to lie in the next roadmap in relation to the support for the digitization of construction. There's fantastic opportunities for both research and, most importantly, for introducing it in industry. So I've finished the points that I wanted to make. If you think the document would be useful to you, can I recommend that you read it? And in particular, the list of references is really the meat of the paper. All 160 references are there. You can see who's published what and where. And as I say, that could be a good starting point for developing collaborations with other people. And I'd particularly like to thank my two co-authors. It's been a pleasure working with them for more than a decade, and I certainly hope we continue to do so. So that concludes my presentation. So we'll take questions if there are any in relation to the first two presentations at the end in the Q&A session. And it's my great pleasure to introduce the next speaker, John Egan. John is founder and CEO of BIMLauncher, which is a data integration platform, construction project management solutions. He is co-founder and podcast co-host at the community innovation platform AEC Hive, and also committee member and technology lead at the Building Smart UK and Ireland working groups. John today is going to talk to us about open information containers, document interoperability for AEC sectors. John, please present your paper.
Hey, thank you. Hello, everyone. So, as Roger said, I'm here to talk about an idea that I have been working on for the last 18 months, which has really come about as a result of the work that I've been doing in my startup, which is all based around the exchange of information between project management and common data environment solutions. So I'd just like to open with the statement that files are the currency of a BIM project, and everything is exchanged in the format of files. Drawings are delivered as files. You know, fire engineers deliver fire reports as PDFs, and really what it comes to is that the file is like the blood of a construction project, as I would call it. Files are also called information containers in terms of when it comes to ISO standards and discussions around this topic in context of open standards like ISO 19650, etc. So the life of a file is something that we have, I suppose, become really adept with in our startup, because essentially that's what we do. We sync files between different systems. Files are, you know, when they leave a system, they are typically leave with 3 general pieces of information, which is identified here. We have the file name. We can take the extension, so we know what type the file is, and generally we have a size of that file. But this all represents information, and it's information particularly in context of the file name, whereby we try to cram as much information into that file name, so that when we share the file with a stakeholder or project collaborator, we have, we try and portray the purpose of that information to the receiver. And generally this is used by the receiver to either parse or to enter into their own project management system. The biggest challenge with the life of a file is that it's like a black box. Because a file is binary, it needs specialized software to read that file. And that content of that file might either be structured data, so it might have format associated with it, like IFC, so that software that supports this file format can parse it, and the computer and the human can work with the contents of the file. But sometimes the file format or the file content is unstructured, and there's no way that we have, or that the receiver of the file has to work with it. If it's a PDF, yes, they can open it in a PDF viewer, but sometimes they don't know even, or they even don't understand the content of the PDF when they do open it. So I did touch on construction project or construction platforms, and the reality of our construction projects today is that there is often many construction platforms or many technology platforms used throughout the life cycle of a construction project. Often you have one construction platform used for design, another for construction, and another for the facilities management stage of a project, and even more beyond that. So typically the way that a construction platform is, I suppose, is made up is of a set of applications, and these applications are like puzzle pieces, and they glue together and they integrate quite well. So for example, if you use an Autodesk system, for example, for design, you will get a tightly knitted puzzle where all of the applications within the platform integrate with one another quite nicely. They share the information between each application module, and the platform works well and works well for the project team. One of the interesting things about each of these applications is that they're often purpose-built. So they're built for a purpose, generally to serve the needs of the stakeholders who will be using these applications. For example, you may have the issue management application within the BIM 360 platform that represents the needs of BIM coordinators on a project, so that they can share issues between different stakeholders on the project. And generally what this means, and as is the nature of application development, is that you have the front-end application or the UI, and you will generally have that database that sits on the Autodesk servers that contains these very valuable data models, which represents the core concepts that are worked within these applications. So if you look at, as I mentioned earlier, there are many platforms used on projects, and as you've probably experienced, many of these platforms have similar applications. So you have a document management application within, whether it's BIM 360, Procore, Oracle that you're using. You have an issues management platform or application, and so forth. So what this means is that you have lots of duplication of applications across many different platforms. And in that, or in doing so, I'm going to just take away the applications and APIs. In doing so, for the purpose of this example, in doing so, you're left with lots of data models that have been built up over the years of knowledge and knowledge gathering of these these vendors working with their customers to really understand, or to really enable their applications to respond to their user needs. So what we have in this particular context is many data models, all representing a similar thing across, many different applications. And the open information container concept works by unifying each of the data models that support these overlapping applications across various different platforms. And what this leaves us with is a schema representing a common way to describe things like issues, documents, submittals, specifications, drawings, and so forth. The open information containers are based on Uniclass. As you might know, the ISO 19650 file naming convention specifies that you can describe the type of information that you're exchanging using a 2-digit code within the file name. At the start of the project, you typically would look through the Uniclass tables. You would identify the different types of information that will be exchanged on the project, and you would assign a 2-digit code with an equivalent Uniclass item from either the form of information table or the project management table in the Uniclass tables. So how this might work in practice. So what is envisioned is that the open information container registry, so a web-based portal where or a web-based API would serve these schemas for these different types of information on a project. Client teams would be able to search through each of the different types of information, and they would be able to prescribe the schema prescribe the schema for use on their projects. If there are any changes to the open information container schema, the open information container schema would be extensible so that the schema can be flexible based on project needs. What this would enable then is that we could build additional query and validation tools that could check these deliverables. So check these information containers for information completeness as they're being exchanged between project environments. So just to recap, open information containers go beyond the classification code that's used in a file name and provide a common language for explicitly defining information intent at the information container level, which can be accessed and used by humans and computers throughout the life cycle of a BIM project. The benefits to the industry would mean that there would be more complete information on the information container, which would mean that there would be less a chore, if you like, to map between different types of information within project management systems and the open information container schemas. And this would obviously make exchange of information between different systems better, because the information will be more complete as it's exchanged. It would also enable the open information containers, or it would also mean that new sources of value could be built on top of the schema, which would provide a more open approach to information containers that are currently held within our project management systems. And these could range from query tools to validation tools, etc. At the moment, there are 4 organizations that are currently working on this. We have the AEC Hive organization that has already had a roundtable with industry leaders to discuss and validate the approach. We have also assembled a list of 140 different properties that could potentially be used on open information containers and that have been identified as useful to the project throughout the life cycle of the project. I'm also aware that University of Maynooth are currently undertaking some research in this area, thanks to the innovation vouchers of Enterprise Ireland, and BIMLauncher and ArcDocs are also where we've engaged University of Maynooth to bring this concept further. So the way that I see it is that information containers are still the currency of the industry. We're still a file-based industry, and becoming better and I suppose more intelligent with the way that we leverage information containers for the purpose of exchange of information, and also for querying different types of information containers across our systems. I see it as really important, and I think that this is the next logical step to advancing both information exchange in projects and improving the ability for stakeholders to communicate and collaborate on projects. And that is me complete. So thank you for listening.
So thank you very much, John, for your presentation. And we are now opening up for discussion for the last 15 minutes of this session. And if I could just very briefly summarize, Brendan led off with a discussion on how the facade industry is going to and is adapting to the benefits of BIM and digital construction. I follow that with a short presentation on a review of exactly which academics are working in which area to use prior references as a repository of knowledge. And finally we finished with John just now talking about a platform for open information containers. So we are open for questions. Please do use the chat facility, Q&A facility on the right-hand side of your screen to ask any questions that you might like. And I might just kick off with a question of BIM for Brendan, if I may. So Brendan, facades is an area of industry that I've worked in for a number of years, and I can see that in other areas of the industry, sometimes groups take a lead and they adopt the technology very quickly, and other times there has to be a reason to do it. And I get a sense from your presentation that the facade industry, while having efficiencies within itself, is not yet can see a way forward in relation to the reasons and motivations as to why they might adapt it. Yet I can see really very significant benefits for them, particularly in BIM 3D and 4D, particularly 4D, in preempting problems on site. And and anticipating those problems, and then later on using the elements of the facade and how the facade performs in terms of a digital twin feedback. Have you got any sense as to whether or not the facade industry is ready for these types of adaptations?
I think the 6 that I interviewed, they could see benefits of BIM, but not in the same sense of where M&E can do clash detection. So I think that was one aspect that kind of made them reluctant to look into it. Another aspect was that they kind of felt that if the BIM process models that are produced could also be used to be used in manufacturing, that would be another benefit for them. But I mean, outside of that they seem to be quite reluctant. Now, I don't know if that's the case for everyone in the facade industry, but that was certainly the case for the ones that I spoke to. Sorry, there was one exception. One of the subcontractors, their arm got twisted, and they had to produce a BIM model as part of the process from design through to construction, and they went down the road of using SolidWorks, which they're only really at the starting sort of a design stage, but they could see the benefits from it already from them, and where they could just go into the model, make a change, and all of their documentation is updated following that.
Yeah, I think, I mean, there are 2 significant reasons for introducing BIM that are clear to me anyway. And one is where a client says they want BIM to be used on their project, and they have to pay a fee in order for that to be the case. And then both the design team and the construction team see the benefit of that. And the other one is where, for example, contractors see that there's an inherent benefit to them anyway. They can see that it gives rise to efficiencies in their business processes. So irrespective of whether or not the client is paying for it, they introduce it themselves. And I think to enable the facade industry to move forward, which is a very large industry actually, and it's a very important part of the built environment, that if the facade industry is going to move forward to adapt BIM more, I think there are 2 approaches. Either there has to be a rationale for them to use it, fundamentally, and see what the benefits are, like the contractors do, to save downstream problems and to see efficiencies on the one hand, or alternatively that they will be instructed to use it by the client, and therefore the fees or the tenders that they put in will have to reflect that, and then that will become the norm in the industry. Would you agree with that?
Yeah, and I think as soon as somebody starts using it in their day-to-day process, others will probably feel they have a competitive disadvantage for not using BIM, and they might follow suit because of that as well.
Yeah, by way of an anecdote, we have a BIM module here in Trinity, or a module in Trinity, a design module for facades. It's dedicated to facades, and all of our students use Revit in order to, we give them a skeleton of a building and they have to render it, but they have to do the research on what type of facade they're going to use and why, so it has to make sense structurally and thermally and aesthetically, and then they actually build a model and they present it to their peers. So we get a whole selection of different solutions to the same problems, and we cross-compare them and we evaluate them. And this is a very good learning experience. It's a good way in which BIM can be introduced to courses in a design project scenario where they're actually using a BIM in this way. So perhaps maybe we should be liaising with the facade companies to invite them in to see what we're doing. If I could turn to John, to ask John a question, if I may. I understood your presentation very well, and I know what the problem is and how you're going to go about solving it. But I wonder, how close are you to actually getting a schema, as you called it, in place, so that a design team and a contractors team could actually start to use the open information container concept that you have? How far are you away from actually using it on a real project so that you can find out how efficient it is and how well it works?
Yeah, well, we are using it right now. So we've been developing these open information containers, and these are the common language or the go-between between the different platforms that we exchange data between with BIMLauncher. So, for example, for a document of type drawing, we have a fixed schema, and we translate to and from the different providers that we support. And it's the neutral language that that can be exchanged between proprietary data models of the different vendors that we support. In terms of the usage by the wider industry, it's not something that we have opened up to the industry yet. So yeah, the goal over the coming year would be that we would offer this registry of open information container schemas in which the industry would then be able to use and build on top of. So yeah, that's where we're at with it. There's other research, obviously the research that University of Maynooth is doing with ArcDocs and our company as well. We would like to think that we'll continue to chip away at it and find the right path forward. We've already tried to approach Building Smart about using their Building Smart data dictionary, as it seemed the natural place to house these open information container schemas, because it also houses the Uniclass equivalent. But I don't think it was quite ready enough for Building Smart to consider it as a candidate to bring into the Building Smart data dictionary.
Yeah, you certainly have very good contacts there to develop that perhaps over the next year or two. And indeed, if you were willing, either yourself or one of your colleagues, to come back in a couple of years, if we have a further CETA BIM gathering, as I'm sure we will, maybe a digital gathering, is that you might come back and report on how that's progressed, because it's certainly it's one solution to that problem of data transfer for sure. So I don't see any questions in the chat room, and if there are no further questions, we're only a couple of minutes from the end of this particular session. So if there are no further questions, I might, and I don't see any, I might just draw this hour session to a conclusion. I'd like to very much thank Brendan and John for their presentations, and also to thank the backroom staff who've been controlling all the various electronics which enable us to make our presentations, and that's been very much seamless and stress less for all of us. And we very much look forward to the next 2.5 days of presentations, as you can dip in and out of the various topics which are on offer. So I'd like to close this session by thanking our presenters, and we look forward in 2 years' time to meeting each other in person rather than by Zoom, where we can network over coffee. So thank you for joining me.
Thanks, Roger.
Yeah, thank you.